Morning, good afternoon, and good evening, everybody. My name is Jorge Diner. I am currently the International Director of Hadassah International, and it's my pleasure to welcome you all to the closing event of our Hadassah International Summer Summit, Health Talks with Hadassah Experts, a journey that we started about 3 weeks ago. This is our 10th event. This has been a journey of knowledge, innovation, ideas, in a very extraordinary period like the one the world is experiencing. We were able to talk beyond what's happening with COVID-19 and looking at the future, present, and developments in health and science. It is really an honor to close this summit with my dear friend, and a friend of so many people all over the world, Professor Orly Elpeleg. Professor Orly Elpeleg, who is a professor of pediatrics and the head of the Department of Genetics at Hadassah Hospital Ein Kerem. Besides the titles, Professor Orly Elpeleg is really an innovator. He's a dreamer, a person, a professional, a human being who cares not only about the big results for science, but cares about the very single life of every single person, of every single patient. And for me, one of the faces of Hadassah in the world, Professor Orly Elpeleg represents the very DNA of what Hadassah mission is: caring for humanity and caring for every human being. Professor Orly Elpeleg has traveled together with me to Mexico twice in the last several months to do something extraordinary, something that she will be reporting as I introduce her and we start the session. She's been to Mexico to look at genetic conditions of people from the Jewish community. And by doing that, not because she was looking for a publication in any article or she was looking for a scientific result, she was just there to help. She has helped so many people, and I'm so moved to see many of those people in the screens in this Zoom. My dear friend Orly, Professor Elpeleg, the floor is yours. For those who are in this session, there will be time at the end for questions. I ask everybody, if you have any questions, to write the questions in the chat. I'll be having a dialogue and leading a Q&A at the last part of this session. Professor Elpeleg, Orly, the floor is yours.
Hi, thank you so much, Jorge, for this introduction, and thank you all for having me and for finding the time to be with us. I should first apologize because I see so many familiar faces, and I'm worried now that parts of my talk are going to be familiar to you because I've given part of this talk both in Mexico and elsewhere. So indeed, in order to understand what brought us to Mexico, I need to explain a little bit about genetics and DNA and diseases. And again, I realize there are some professionals here and very high rank ones, and I'm very honored to have you all. But I would try to explain as basic as possible. So perhaps you want to go and get some coffee and then come back in 15 minutes so that we are all on the same page. Well then, let me now share my screen and start my talk. Right, so what we are doing at Hadassah is that about 15 years ago, we started an undiagnosed patient program because we realized that it's very easy to identify patients with infections and malignancies, but many patients do not fall into any of these categories and they remain undiagnosed. And we suspected that many of them are actually having a genetic disorder. And I can give you already here the last sentence of this talk. so you don't have to wait impatiently, and that is that still for rare genetic disorder, the best therapy is prevention. We still do not have therapy for more than 95% of the rare diseases that we identify. So what it's all about, these genetic disorders. So 20 years ago, President Clinton was standing and was honored to announce that the Human Genome Project was completed, at least the first draft. And by that, he meant that the 3 billion letters from which the DNA consists, their sequence is known. So this was a huge effort, which indeed took 13 years and cost, I think, $3 billion. Just to, in short, at the moment, we are doing the same thing in 2 days, and it cost us about $2,000 to read the entire genome. And we are, I'll show you in a moment, we are reading a shorter version of it to make things simpler. So what President Clinton was telling us is that actually by knowing the sequence of the DNA, we are learning the language in which God created life. And indeed, the DNA is made of 4 letters, A, C, T, G, and the whole story is about how the sequence is of extreme importance. So we all started looking at this sequence 20 years ago, and we realized that here and there we recognize genes, and there is a lot of material which is intergenic. And so we defined the genes. We know that there are about 22,000 of them. And in year 2000, we could not say much about their function. So about 50% of the genes, we didn't know what their function is. And we immediately thought that if we can identify patients with mutations in these genes, maybe we can tell even something about the function. That was not the purpose, but it could be a side product, you know, a byproduct. So our mission was actually to associate between our undiagnosed patients and a single letter changes. Well, by saying single, I'm kind of simplifying it. Sometimes it's more than 1 letter, but basically it still amazes me up to this day to realize that an entire patient, the life of a family, can be completely ruined by a single letter change. If this letter is of importance, and we have many parameters to decide if a change, if a variant is actually a disease-causing mutation. That's one of our challenges when we read the DNA. Because you know, all of us have variants in the DNA. This is why we vary from each other. By these variants. Most of the variants are benign. They are not causing a disease. They are just maybe responsible for our beauty, wisdom, you know, things like that, but they do not cause disease. So we are trying always to filter the variants that we identify and to find the single one which is responsible for a disease. That's very important. Not only because we can then check future children, but also because maybe we can design therapy directed at correcting the error. So how do we transmit a genomic variant, even if it's a disease-causing mutation or just a simple variant? So I decided, in order to explain that, to use a family which I think many of you are familiar with. And so you can see that there are several ways to transmit a variant. One way is the dominant. So say if this woman has a disease because of a variant in here, she can transmit it to her son. So this is a dominant transmission. Usually dominant disorders are not occurring very early in life. Otherwise people would not be healthy enough to reproduce children. So they are either late onset or are of milder severity, if one can generalize about dominant condition. Then there are also disorders where the variant occurred de novo. And so The patient has a disease because of a variant, but both parents do not carry it. And this is a rapidly evolving spectrum of variants that we are now discovering thanks to new machines that was donated by the couple that I was just so honored to have with us today. So de novo mutations are a very specific class of disorders. But what we really specialized in are recessive disorders. These are disorders where the parents carry a mutation, but it doesn't give them any trouble, usually. But when both of them give the mutation, so the child has 2 copies of the mutation, then and only then he is sick. And this is something we have worked on for the past 2 decades intensively. So how does it happen that 2 people would have exactly the same variant and would match and marry and have kids? So you have to understand that this is amazing because there are 3 billion letters in the DNA, and to have exactly the same change, wow, what a coincidence. So let me now put it in a very schematic manner. This is the wife, this is the husband, and each of them have 2 copies of every gene. You know that we have 2 copies of every gene, one from our father, one from our mother. Now say that both of them have the same genetic mutation on 1 copy. So they are healthy because they still have the 2nd copy, okay. But they can produce a child where both of them will give the disease copy and the child will have 2 copies, okay? So now we are not any longer in the royal field, but in the real world. And how can that happen? That both of them would have exactly at the same spot, the same change. The way to understand it is to think about this grandfather. This can be any grandfather. This grandfather has, as we said, a disease-causing mutation. He doesn't know it, of course. Each one of us carry about 4 to 5 disease-causing mutations. But we have the other copy to compensate for it. His wife do not have any trouble. Okay, now they are having 2 daughters. The daughters, each one of them got the disease copy. But from the mother, they got the red or the blue, both of them protect them. So they are okay, they don't even know that they carry. Now each one of them is getting married and having a child. Here there is a boy, here there is a girl. These youngsters are first cousins. Each one of them now carry the same, exactly the same mutation because it came from the same grandfather. So of course it's identical. Now what happened? They produce a child, and this child is going to be sick. And this is how recessive transmission works, okay? Not in every child of this couple there would be a sick child, because in 75% of the cases, they will have a healthy child, but in 25%, there would be a sick child. That's what happens when the parents are related. They don't know it, but it can happen. Why do we have all these patients? And we have many of them. And the answer resides in this map. This is the map of consanguinity, of marriage within families. And look at Israel. Israel is one of the darker areas in this globe. Namely, that we have in some of our communities, we have about 50% of the couples marrying their 1st or 2nd cousin. So therefore, we see a lot of children with recessive disorders. So how do we solve this problem of diagnosing the patients? I've already told you that we don't know for most genes what they do. How does a gene look like? A gene is made of exons and introns. The coding part, the important part, is the exons. these yellow fragments here and here. They consist only 1 to 2% of the DNA, okay? So if this is the entire DNA, the exons, which together we call them exome with ME at the end, are only a small part of the entire DNA. But about 85% of the disease-causing mutation resides in them because this is the important part of the DNA, the exons. So if I take only all the exons, I can quickly read their sequence and identify the mutation. So this is a good deal. We pay little in order to read little, but we gain a lot of information. So we have excelled on running exome analysis. And this is the machine, okay? This is the Novasec. In reality, it looks much bigger, like a huge washing machine. And what we are doing is that we take the DNA of our patients, we break it, we extract the exons out of it, we put them into the machine, and the machine gives us back their sequence. So now we know their sequence, but we don't know where they came from. So then comes the bioinformatics stage, where we have to align them and compare them to the DNA of a normal person. Now, who is normal? Obviously, all of us are normal, but we are different a bit. So it's okay to find variants. So this is the normal DNA, so-called, and this is the patient DNA fragments that we just put under one exon, under another exon, and you can see how they accumulate. Now let's zoom in, and you will see this is the reference, the control sequence, and this is our patient DNA. The green and the blue is of no importance. It's just the direction in which we read it. Sometimes we read from left to right, sometimes from right to left. But what is prominent is that here there is a change. It should be G and it's A in every fragment of the patient. That does not mean that he is sick or that this is the cause of his illness. It just means that there is a variant. Good. So now we all know how to read DNA and in which machine to put it and how to identify a change. And we always say that one photo is better than 1,000 words. So let me tell you about Toar. She is my celebrity. And I've seen her some 10 years ago. At that time, she was 2 years of age. And she was the third child of a North African Jewish couple. She looked completely okay for the first 6 months of her life. And then she had a weakness of the lower limbs, of the legs, during a febrile illness, some very mild feverish disease. And she couldn't move her legs. It lasted for several days, and then she regained some of the strength. And at about 1 year of age, she had another episode of some fever. I think it was an ear infection. And at that time, the upper limbs, the arms were also involved. By the time when I saw her, she had her intelligence was striking. She was completely normal, but she was extremely weak to the point that, of course, she couldn't support herself while sitting. And she had some movement of the fingers, and she kept her head okay, so the neck muscles were fine. And that was it, more or less. Parents were terrified. They felt that if they exposed her to other children, she would catch some more febrile illnesses, and they would lose her. All her tests suggested that she has some hyperactivity of her inflammatory response, as if she's facing constantly some infections, but there was no infection. And she was tried on every anti-inflammatory regime possible, and nothing worked. Parents once said, you know, you really have to find what's wrong with her and fix her, because we cannot afford losing her. And they had, beyond what is expected from every parent, they had a very good reason, because this is the couple, and father, mother, healthy daughter, then Tohar, and then they had a child whom they lost at the age of 5 from the same disease. He had similar episodes, and the last one involved his respiratory muscles, and he died. So it was clear that they cannot go through that again. We immediately launched a call all over the country. This is a small country. We asked for North African Jewish kids that experiencing muscle weakness during febrile illnesses. And I think within 2 days, we had 3 more families. So this is the original one, and there are the 3 more. We didn't have much money at the time. We decided to take this girl here because the parents told us that they're first cousins. So we assumed that it would be easier to work on her. So we read her exome. We read only the exome parts of the DNA, and we came up with a mutation which seemed to be disease-causing, but we didn't understand anything about it because, as usual, I don't know anything about the genes where I find the mutations. So this was a gene named CD59, and for, I think, a couple of minutes, I was completely puzzled, and then I thought, well, you always have to believe that in Hadassah you will find somebody, and indeed there was Professor Dror Mevorach, head of internal medicine B, that was spending a lot of his career on this protein. So I rushed to his office and I said, you know, CD59, what do you know about him? He said, aha, that explains everything. And he immediately showed me the same cartoon that I will show you. Apparently, when we meet a bacteria, our immune system is generating this kind of a channel. Here it is cut into the half, so you will see it's inside, but it's round. And it's made of subunits of complement system, and it's called membrane attack complex. And this channel is used to puncture, to make a punch in the wall of the bacteria, so that water will get in and destroy it completely. It's a fantastic process. But once the bacteria is gone, you have to stop generating these channels. And the way of doing that is simply by generating this CD59. So CD59 comes in and would not allow the generation of these channels, okay? So the process is stopped. So CD59 is really required. What happens when CD59 is not there, like in our patients? Well then, the channel continues to be generated. The channels continue to be generated, and now they are attacking the myelin. Myelin is the insulating layer of the peripheral nerves. So no wonder that our patients are becoming weak, because they cannot transmit impulses to the muscles because their peripheral nerves are demyelinated. There is no myelin on them. This was the hypothesis. And then Dror Mevorach said, you know, but I have a surprise for you, because actually there is a drug on the shelf. An FDA-approved drug, probably the most expensive patented drug that Israel is currently supplying its 5 citizens. Eculizumab is actually designed for another disease, but it would interfere with the generation of this channel. So let's start giving it. I would not now exhaust and use our time to tell you what the process we went through. Suffices to say that Alexion gave us a $2 million compassionate use drug to start it. Parents were hesitant because they understood that we are going to suppress their kids' immune system. There was a lot of debate, and we needed many experts to interfere and to guarantee that we are not going to kill them. And then we started giving it every 3 weeks by intravenously. We didn't see them for a while, and then we decided it's time to look at them. So this is Tor dancing on her 3rd birthday. You can see that she still has support for her ankles. They are still weak, and she would fall if she doesn't. This is Mevorach with another child, and this is a girl showing me, and not the first girl, the one that we sequence her DNA, and she's showing me that she can raise her arm. Now, this is not a cure. This is a therapy which works, and on day 19 or 20, you can see that they are getting weak. So they need it really every 21 days. And everybody is looking for a better solution, but currently for the past years, we are totally dependent on this drug. So this was just the exception, the situation where a genetic disease ending, a genetic diagnosis ending up in a therapy. It's not always like that. But, you know, using this strategy, we were able to identify about, no, now it's about 110 disease-causing genes that were not known before. And we were able to tell the world the function of these genes, which was not known. And you can see that one of them is our CD59, which I've just told you about. And we are running now exome analysis for almost every undiagnosed patient. It became like our blood count, you know, it's so elementary that we are doing it with everybody. So on the red is our data, and on the blue is the world data. And you can see that in some diseases we are very good, like with autism, we discover in 30% of our patients the cause. But in intellectual disability, we are, well, we are doing not so bad. With epilepsy, we are better. But what I want to show you is that we are not at all in 100%. So a significant proportion of our patients remain undiagnosed, waiting for our next step. And we have created a database, which we called Hadassah, and has been accepted warmly by the world. And this is a database of all the variants in the ethnic groups. And you can see that about half of our exomes belong to Arab Muslims and half to Jews. Among the Jews, you can see that Ashkenazi are about 40%, multiracial is 46%, and the rest are just small percentages. Let me just show you that the Syrian, and that is important for the, in the coming minutes, the Syrian consisted of a very tiny portion of our database, which was produced a year ago. Good. So looking at our database, we realized that there are founder mutations. These are mutations that are common in the population. And then it can happen that a couple, even if they are not first cousins, say that they are fourth degree cousin or fifth degree cousin, like many Ashkenazi, they would not even know about it. They would bump into each other in a pub in Tel Aviv and would end up with a sick child, not knowing that they were carrying actually the same founder mutation. So Ashkenazi people, they have now a screen, premarital, which they are using, at least the very religious ones, that consist of some, I don't know, 100 variants, or no, maybe 30 only, that they are checking to see all their youngsters. But what do you do with communities that do not have such a known founder mutations? And over the past 3 years, we have encountered founder mutations in the Syrian-Jewish community in Mexico and in Panama. And what was really frightening was that both parents were not related, yet they carried the same mutation, telling us that these mutations may actually be founder, they may be common in these communities. One disease was a disease which affects the brain and cause an arrested development and epileptic-like episodes. And the other one, photo is shown here, is a muscle-related disease, which really slows patients' motor development and cause a lot of issues. Now, if such a couple that carry the same mutation are getting married, as I told you, 25% of their kids would be affected. And what we wanted to do, and what the Mexican Jewish community was discussing with us, is not waiting for the first child to be born with a disease in order to understand that actually the parents carry. They say, try to identify for us the founder mutation before the birth of the first patient. Tell us if this young, beautiful looking couple that just met in pub in downtown Mexico City, no, they're not meeting downtown, in the Hebrew speaking schools in Mexico City. Tell them if they are both carrying this founder mutation. Because then, if we do that, we can either offer them prenatal diagnosis at week 11 or 12 of the pregnancy, if they so wish, or if they prefer, we can offer them in vitro fertilization, test your baby with pre-implantation diagnosis on day 3 or 5, and then returning the embryo only after we assure the parents that the embryo is healthy. So this way, if we can identify them before the birth of the first child, we can then prevent the birth of affected children. So we have launched the Mexico Exome Project 1, 2, and this week we started project number 3. First project ended in February this year, and second one in May. There are some people among the audience, and I would not say names, so I would not forget any, that have made a huge effort. I have never seen non-medical people working so hard for the success and for their community, as you can see in the Mexico City Jewish community, really. So altogether, in the first 2 projects, there were 113 couples that had their exomes sequenced in order to identify if they both carry the same genomic disease-causing variant. We were facing the COVID-19, and therefore the second project was done by Zoom. So in 8 days, we were doing 7 Zoom meetings, 3 hours each, and we have seen 166 individuals to advise them regarding their exome analysis. Now you have to understand, it's not only about matching, because most of them elected to know also secondary findings. So, okay, they really want to know if they both carry a disease causing, but they also want to know if there is any cancer associated gene that they should know about, if this is an actionable. So we are only informing people about actionable variants if we find them. If there is a heart disease condition they should know about before even it produces any symptoms, we notify them about it. But that requires to sit in front of every couple in person to discuss and to explain. And we have done 166 people in 21 hours. Just for comparison, in Jerusalem, we see 5 couples in 3 hours clinic. So that was a marathon, and I'm very happy to say that it worked very well, only because of the local people, of the leadership of the community in Mexico City. So what were the findings in the 133 couples? We found 5 couples sharing a severe disease. That is huge, because none of them had any sick child by the time we identified them. We found 1 woman with severe X-linked disease. So she's healthy, but half of her sons will have a disease which would cause them intellectual disability and epilepsy. So this woman has also gained a lot of information from this analysis. We then found 2 people that had symptoms and did not know why, and we found their disease, which is dominant, autosomal dominant disease. These people too would elect to have now not to transmit their disease to their children. Now they know what it is. Then we found some 8 women with mild X-linked disease, which we just informed them of it because it's about, Jorge, you know what is the name of ful. They should be careful with eating ful, favisen, but nothing more than that. It causes anemia hemolytica, you know. And then there were 7 people that we have informed about having heart issues and send them to cardiologists to have their heart rhythm monitored, because these people otherwise may collapse one day with the arrhythmia, which can be fatal. So these people are going to be now under observation for their heart rhythm. And then we had 2 people where we, before any symptom, we informed them that they may develop cancer later in life and explain to them what to do in order to detect it early. One of them would have mammography, although she's 25 only, and one of them would start having colonoscopy. So this information is very important. And there were 7 couples that shared a mild disease, and we advised them not to do anything about it. So what is the summary? The summary is that 7% of the couples, 8 couples, are now going to have a prenatal procedure in order not to have children with disease that may kill them. Then there are 9 individuals with secondary finding that will now start follow-up or therapy to prevent a life-threatening disease, either cardiac or cancer. Altogether, 17 families out of 113 have a life-changing finding. This is 15%. We have also created a database of variants because we wanted to know if they are founders. If we can now offer them a panel of mutations that they would only look at them and then they can decide whom to marry or what to be careful of. So now we have done 236 exome, and this week we received another 74. So we have now over 300 exomes from the Mexican Jewish community. Not all of them are Syrian, of course. We found in them 223 known disease-causing variants, both severe and mild. But what is more of concern to me is that we found in them 100 loss of function variants, which are not known before in literature and in other populations. So this would not be identified if not for doing a real reading, you know, bias-free reading. And so we still cannot design a panel of common disease-causing mutation, and we still advise people to go for the entire whole exome because there is so much to gain, 15%. And I thank you now, and I stop sharing my screen.
Thank you, Orly. I think it's fascinating to see the last slides, the impact. And again, I know some of the people who are watching this session now, who are involved in this project. And I think, you know, the first question I want to ask you relates to the difference between what you are doing and what has become lately all this very popular, you know, genetic full panels testing, all kind of diseases that includes also what's your background, you know, for obvious reasons. I'm not going to mention specifically any company that is doing this, but there are all kind of like very big private companies in the world and many other small companies and other institutions offering all kind of genetic testing to everybody. And I think it's important that we clarify the difference between what you are doing and what these other options around represent.
Well, I can only tell you that we are trying to be very conservative. So, you know, you can bombard people with a lot of genomic information, which would leave them very confused and sometimes even terrified. I think it's really unnecessary. People are asking if you instruct them, they can formulate a very specific questions. Most of the people that we meet, either they want to know what's wrong with their child because their child is very sick, or they want to know if their match with their partner is okay or it may produce a serious condition. So these are the things that we try to answer. And also we're trying to answer secondary findings. This is cancer and the heart issues, only if they are actionable. You know, I don't know the gene for Alzheimer, but even if I knew it, I would not tell it because is there anything you can do? Anyway, you are doing Sudoku every day and studying foreign languages. So we all do that. And so there is no point in bombarding people with information which is non-actionable, which would not really enable them to do anything different from what they're doing right now. And becoming frightened of information, what's the point of that?
Yeah, I think, you know, in terms of what you are, the work that you are doing, and having been part of the project that you are running in Mexico, I had the opportunity to see this firsthand. Is you're coming basically to discover and find things that are, as you say, as you share us tell all the time, is actionable, things that people can do something about,
Yeah.
being it while something appears that they can do when they are already alive, or something that you can do to prevent that babies are born with conditions that they could carry, and so far today are very challenging to be treated or to be cured. So I think that, you know, that's one of the important things that you mentioned, is the point of actionable diseases. Now, when you look at the future, and you look at and we have many conversations, when you look at the next years, and we see you as one of the leaders in this field, not just in Hadassah or in Israel, but in the world. When you look at the next years, how do you see these actionable items being expanded, so that there could be actions that could be done through genetic screening in other ways? You know, we spoke about genotyping certain diseases, like in neurology, or in cancer, or in other diseases. So how do you see this field expanding?
I think that the real player are the people that suffer, the people that really want us to look to have our spot and focus on their disease. And if they come to us, we can certainly at least diagnose them. As I said in my first slide, if we diagnose, then we can either prevent, or in disorders where the patients are already there, we can try, and we and others can try to design a therapy. So naming a disease, identifying exactly the spot, is of extreme importance. And this would continue and extend and expand. And we now look at adult onset and at third age, at late onset disorders, because we realize that there is a genetic background to that as well.
So are you saying, in a way, that we are moving in the field of genetics is moving, I think, based on your experience and the experience of centers like yours, are we moving in some kind of like personalized medicine, where we can look at the specific mutations of different people and help understand how we can provide solutions to people with specific conditions?
Yeah, I think
that's what you're saying.
Yeah, exactly. I think that some mutations are really offering you immediately, when you look at them, a solution. Others, it would take much longer, but you must name it first and put your finger on the exact error before you can start thinking of a therapy. That's for sure.
Yeah, you know that one of my main roles leading Hadassah International is to support the dreams of our experts and our geniuses at Hadassah, and I count you as one of them. And I think we have been dreaming together about how we want and where we want to take your activity that has been extraordinary to new horizons, and trying to find specific solutions for different existing diseases and diseases that we still don't know. So if you have to think about your dream, what is the dream that you have for where you see?
The dream is really to have a center that would try and take one disease after another and find a platform for each disease where you can screen FDA-approved drugs or molecules even, and there are now libraries of such molecules that you can screen patients for it. Now, you are not going to take the entire patient and try 9,000 molecules, each one, but you can do it if you take a patient skin or a patient stem cells and use that as a platform to screen libraries of drugs. So this is a high throughput screening. And this is the kind of facility that I would dream of having at Hadassah. So there would be a pipeline. First, you diagnose the patient at the genetic level. Then you generate a platform, say a stem cells that mimic the disease of the patient, but in a dish, in a test tube. Then you screen for this the library against the patient's cells, and then you can come up and say, oh, here are my candidates. This is start being done in some places in the world. I think that Hadassah has the capacity of doing the same, but it requires, you know, a lot of effort. It's not trivial.
This really sounds like science fiction, but I think, you know, writers of science fiction write fantasy. And I think writers like you write the next code that can fix disease. And I think that in that sense, I admire, I think, you know, we all admire the work you do. And I think there is something I want to mention as we're getting to close this event. I think there is something extraordinary about reaching to the Syrian-Jews in Mexico, in Panama, and in other places, because in a way, you know, we have seen the Jewish war, that Ashkenazi genetic conditions have been more explored, and I'm talking as an Ashkenazi myself, but more explored, and there are panels that really have looked, and you know, you've been involved in this in many projects, and if we had time, we could go also into that part of the conversation, but not for this.
Just one thing, Jorge. For the Ashkenazi. The Ashkenazi never had a project similar to the one of the Mexican Jewish community. They always had first 10 or 12 children with a disease, and only then they came up and say, oh, there is a founder mutation there. So what the Mexican Jewish community is trying to do is extremely advanced and cutting edge in a way.
Yeah. That's amazing. I think there are many questions, and because of the lack of time, we will not have time to answer all the questions, but we'll make sure that we'll get these questions to Professor Elpeleg, and that we will send all of you the recording of this session. All the participants will get the YouTube link to the session, and for the questions that you have asked, we will try to get you all the answers from Professor Orly Elpeleg. And I want to thank you, Orly, for not just for this presentation, but for everything that you've done for so many people, and particularly in the case of the Mexican Jewish experience. I think I can speak on behalf of all our Mexican friends. This has made an incredible difference, and I'm sure that this is going to be a pioneering experience. Again, in the spirit of Hadassah being pioneer for more than 100 years, this has been another pioneering experience that I'm sure will be replicated in other parts of the world, in other communities that are not part of the Jewish community, where this can also prevent disease and help families have a healthy life. Orly.
I just want to say about the Mexican Jewish community. You know, I'm getting old, but I still learn new lessons. And the lesson from the Mexican Jewish community in Mexico City was, this was a real example of Kol Israel Arevim Ze Laze. You don't see it in many parts of the world, but what we have witnessed there is something which was extremely moving. This is a community which care for each other. It brings me back the understand why I want to be Jewish, you know, because the way they are conducting their community, it's an example for everybody. I came back from there and went again and again because I really admire them. They're fantastic.
Yes, they are, and we are very proud of having this incredible and extraordinary connection between Hadassah and the Mexican Jewish community, and having been able not just to receive the generosity of the Mexican Jewish community that has been extraordinary for Hadassah, but also being able to do something for the Jewish community in Mexico. This is time to thank many people. I think there are many people who I need to thank particularly for this project. Of course, there are two people who are very important for everything we do in Mexico. Ethel Feinstein, our director of Latin America, who lives in Mexico City, who is here greeting everybody. Rafael Saga, the president chairman of Hadassah board in Mexico. There are three people who have been running this initiative in an incredible way: Ceci Meta, Olga Sasson, and Elvira Saga. If I have a time, I could say a lot of words for each one of them, but I think I can only say that in the middle of lockdowns in both countries, in Mexico and Israel, they were testing people, getting blood tests, shipping those blood tests, so Orly in Jerusalem could get results to these couples and then present these results. It's not as easy as it looks in the middle of this COVID crisis. To make that happen, it's really extraordinary, and it's something that I wanted to mention. I want to mention the Edith family. I think Becky's there, is here. I'm not sure your father, Isaac, is here.
Elvira is also there.
Elvira is here, and you have been not only at the beginning of this entire initiative and personally involved because of your personal family challenges initiating this, but also supporting the work of Orly in Jerusalem to make sure that we can expand our activity. And now it's time to
Jorge.
Yes.
Judy and Sydney Schwartz, thank you guys for making my dreams into a reality.
Judy Schwartz, if you want to say a word to Professor Elpeleg.
Sydney met Orly even before I did and saw in her pure genius and adored her. And there was something very, very special. And this goes back many, many years ago when it was with Shlomo Mor-Yosef and Osnat Moskowitz, who I happened to even speak to yesterday. And that made that shidduch happen while I was at a meeting. And it was, we're just enormously grateful to Shlomo and Orly for introducing Sydney, and Osnat for introducing Sydney to Orly, because it became a love affair and a huge admiration, because this is groundbreaking. This is genius lady, and we're just so proud that she is able to do the work she is. It's an honor for us to have.
Oh, now I will cry. Stop.
All right. We love you. Just stay healthy. Doing all right. Yep.
I think, you know, this is a very interesting way of looking at the kind of impact that when people support an institution, and when people support, and for those who don't know, Judy and Sydney Schwartz have been outstanding supporters to Hadassah, and we are very grateful for that. I didn't have the chance or the privilege even to meet them personally yet, and it's my first time, but I heard so many things, and I'm aware of the incredible support that you have done. And these kind of things that Orly presented today show the impact that has supporting an institution like Hadassah, impact that can fly, you know, thousands of miles away to people in other parts of the world at the end of the day. It's not just supporting Jerusalem, it's not just supporting Israel, but it's supporting humanity. And this session was such an incredible example of how knowledge, know-how, and healing can be replicated and can be transferred to so many places. I want to close this session and close actually this summer summit. As I said at the beginning, we really plan having Professor Elpeleg, and as I call her my friend Orly, to close this summit, because we wanted to close with a highlight. We wanted to close in the highest place we could be, so we couldn't have a better choice but to have Orly. I want to thank you, Orly. I want to thank you and all the experts at Hadassah that have been presenting in the last several weeks. This has been an extraordinary journey. All these sessions are available online. If you go on YouTube to Hadassah International, they are all there. If you want, we can send you other presentations. I want to thank two people. One couldn't be here today on my team, Attila and Jan, who have developed all this summit in a very short time, and you know, there are organizations that have teams of dozens of people and spend months to plan what we plan, in just a few days with a very small team of people. I want to thank the leadership of Hadassah International, particularly Joyce Rabin and Rolf Dorfman, our president. I want to thank Melissa Kaplan, who is now on leave, but it's here in spirit. I want to thank Audrey Shimbron and Guido Melmet for being partners in this. And I want to thank the over 3,000 participants from more than 25 countries who have been participating in these sessions at part of the Summer Summit of Hadassah International. We are a truly international network of people who care about humanity. We care about everybody, and we care about each one of them. Ethel Feinstein, want to say one word, and then I will close.
Of course, I want to thank Orly Elpeleg, but also I want to thank especially Sydney and Judy Schwartz. Judy was the chair of the tower, and she was the soul, she was the guide, and she was our mentor to build this outstanding tower at Hadassah Ein Kerem. So I want to thank Judy and Sydney very special, because they are the kind of people that help us to build and to promote this kind of specialists, this kind of genius as Orly Elpeleg today. And thank you, as Jorge said, to all the people that participated in Mexico, more than 1,000 people in this kind of conferences. Thank you very much.
So once again, thank you all for participating. Thank you, Orly, for this extraordinary session. And for all those who wrote how we can connect, we are going to send all the information that you need by email. Thank you very much. And we will see you soon with our next activities. It's a pleasure and an honor to be part of Hadassah and to be able to dream together with you. Thank you very much. And now I would just open the mic so people who want to greet or say goodbye, they can just say thank you very much.
Bye. Thank you.
And I keep,
Thank you.